Howdy Hawks. Let's go ahead. I'm going to show you the complex numbers unit. This is the link I sent you guys. Let's click on that. Okay, so it looks like this imaginary unit I, complex numbers introduction, the complex plane, adding and subtracting complex numbers, multiplying complex numbers. They're not even going to make you divide. Quadratic equations with complex solutions, and then the unit test. There are also 2 quizzes along the way that you can take to kind of see where you're at. Doesn't look like there's too much. I'm just going to hit up the unit test so we can see all the questions that we're going to be seeing. Plot 7 plus 3i in the complex plane. Now remember, this is the real line number. This is the imaginary. We're doing 7 plus 3i. This is 7 in real. This is 3i. So that's 7 plus 3i, right? The 7 is the real coordinate. The 3i is the imaginary coordinate. The 7 is the x coordinate. The 3 is the y coordinate. Addition, right? Remember, you're just adding, you're adding the real part to the real part. Okay, so we're getting 44 negative 9i minus 6i minus 15i. Here we're multiplying. Negative 5 times 5 is negative 25 I squared. So we're getting, oh, this is going to be so much easier with the writing tablet. Okay. Okay. So we have right, negative, oh, whoops. Negative 5i times 5i minus 5. Negative 5i times 5i. Negative 25i squared plus 25i. And all I did was multiply this to this, and I multiplied it to this. Okay, well remember, I squared is just negative 1, so this is negative 25 times negative 1 plus 25i. Negative 25 times negative 1 is 25, so we just have 25 plus 25i. The next one, we're taking the square root. It says express our answer in simplified form. So we are going to have to break down this 70. Okay. That's 7 times 10. That's 2 times 5. There's no perfect squares, right? 7, 2, and 5 are all different. If it had been, say, 12, right, that would be 3 and 4, 2 and 2, right? Notice this would give me a perfect square. 2 times 2 is a perfect square. There's no perfect square. This is 2 times 5 times 7. So we're just going to keep the square root of 70 in there. Okay. We're going to pull the square root of negative 1 out front. That negative 1, right, the negative inside of there, I'm just going to put that in front as I. So now we don't have any kind of square root, and we still have the 70, right? We weren't able to simplify that at all. Check. Z equals 77 minus 27.8i. What are the real and imaginary parts, right? The real part is the part without the I. So the real part of Z, the real part of this, is 77, right? So this could be the answer, or this could be the answer. What is the imaginary part? Well, the imaginary part is this part, right? The negative 27.8 I. Right? And so you're tempted to pick either of these. It's going to be these. It's going to be this one because this is the whole imaginary part. It doesn't like that. So it's actually saying that this is the imaginary part So they don't want you to include the I when they're talking about the imaginary part. Let's see why they're saying that. Yeah, get a hint. The imaginary part is just the B. So he's saying it's the part without the I. So it's the part where the I is minus the I. If I had given you a test and I asked where the real and imaginary parts were, I wouldn't have cared if you left the I there. I'm not sure why he's distinguishing, because this is clearly the imaginary part with the I, so I'm not sure why they're removing the I. So just be aware that they mean the imaginary part is the part without the letter I. Which of the following is equivalent to the complex number I to the 19th? This is kind of a tricky question. Remember, I squared is -1, right? I to the 4th, oh, this looks terrible when I don't use my tablet. Okay. And so I squared equals -1. I to the 4th equals -1 squared, which equals just plain old 1. More specifically, let's actually look at what this would look like. Let's do I to the 1, I squared, I cubed, I to the 4th, I to the 5th, I to the 6th, I to the 7th, I to the 8th. Let's just do just these. This is just I. This is -1. -1 times I, negative I. Negative I times I would give me +1. Uh-oh. Not sure what happened there. I to the 5th would be 1. Right, would be 1 times I. So this is just I again. You know what, let's delete everything. Start this over. You too. Okay. Let's start it right here. Okay? We have I to the 1, I squared, I cubed, I to the 4th, I to the 5th, I to the 6th, I to the 7th, I to the 8th, I to the 9th, and so on, right? I to the 1 is I. I times itself is -1. -1 times I is just going to be negative I. Negative I times I, well, I times I is -1. -1, this is just +1. 1 times I is I. I times I is -1. And I times -1 is negative I. Negative I times I is going to give me +1 I. And notice this actually makes a pattern. Alright, you can actually see this pattern pretty easy. I, -1, negative I, 1. I, -1, negative I, 1. I, -1, negative I, 1. And notice what these numbers are, right? This is 1, 2, 3, 4, 5, 6, 7, 8. If you're divisible by 4, you're just 1, right? So I to the 100th, well, 100 is divisible by 4. That's just going to be 1. If you were 1 up from there, right? If you were 1 more, I to the 100 and 1. Well, 1 times I is I. We want to know the 19th. Well, that's 1 less than 20, and 20 is exactly divisible by 4. So we know I to the 20th equals 1, because 20 is divisible by 4. Looking at our pattern, here's the ones divisible by 4. The one right in front of that is negative I. So I to the 19th must be negative I. So right there. This is new. You may want to watch the video on this one, but this basic pattern will hold all the time. What type of number is 90.65i? Well, since it has an I, we know it's imaginary. We notice we're not adding any real component, right? All it is the imaginary part of the complex number. You're almost there. Oh, choose all answers that apply. Every imaginary number is a complex number. That was kind of a trick question. I didn't see the choose all. We're probably going to do this unit test twice to make sure we get all the right answers. We're going to multiply. This doesn't look too bad. We did problems just like this in class already. -3 plus 2i. Alright, 2 times -3 is -6. 2 times 2i is 4i. -I times 3 is plus 3i. -I times 2i is minus 2i squared. 2i squared, right, that's just -2 times -1, which is really just plus 2. This part, right, 4i plus 3i, that's 7i. So we have -6 plus 7i plus 2. -6 plus 2 is -4. So we're getting -4 plus 7i. That wasn't too bad. -4 plus 7i. Okay, find the solutions of the quadratic equation 14x squared plus 9x plus 10 equals 0. Okay, you're generally going to do this using the quadratic formula. You can complete the square on these. You're probably not going to be able to factor this. In fact, this one, you're ending up with these terrible fractions, so you're almost definitely not going to be able to factor it. Remember that the quadratic formula looks like this. And if you haven't heard the Pop Goes the Weasel song, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. Alright, and we're just going to do that same thing but with the numbers that we have, right? -b, well, b is 9, right? This is my a, this is my b, this is my c, because it's in standard form, right? ax squared plus bx plus c equals 0. So this is my a, this is my b, this is my c. So we have -9. Oh, well, that makes it easy. That means this can't be the right answer, and this can't be the right answer, because we know we have a negative. Okay, so we have -9 plus or minus the square root of, oh, all we're checking now is to see whether or not it's imaginary on this part, right? Here we see that it has an I. The only difference is this one doesn't have the I and this one does have the I. So we're just going to figure out what's inside of here now. B squared, right, is 81. And we're going to be subtracting 4 times A times C. Well, 4 times 14 is 56. 56 times 10 is 560. So we're doing 81 minus 560. And this is all over 2 times 14. Although really all we care about right now is what's happening here. 81 minus 560 equals negative, well, we already know it's going to be negative 479, but let's use a calculator. Double check. You don't ever want to just trust what the computer's telling you. Okay, so 81 minus 560, negative 479. Right, negative 479. Well, the square root of a negative number, right, we are going to get something imaginary. Right? This right here is going to mean I need something imaginary. So the 479, that's not going to change. But now we are taking out the imaginary part, right? The square root of negative 1. So we're getting I root 479. I root 479. And both of those are still over 28, right? This 2 times 14 right here. So it has to be this one. Show summary. Okay, we got one wrong. And definitely want to do that again. Go through it a little bit quicker this time. Since we already have seen some of these. Okay. Negative 2 times 2 is negative 4i. Negative 2 times 6 is negative 12. The I makes it negative 1. Negative 12 times negative 1 is positive 12. Negative 3 minus I times 3 plus I. Right, so we have negative 3 minus I times 3 plus I. Negative 3 times 3 is negative 9. Negative 3i, negative 3i minus I squared minus negative 1 plus 1. Negative 9 plus 1 is negative 8. Negative 3i minus 3i is minus 6i. So for that one, we're getting negative 8 minus 6i. This one we're subtracting. 8 minus negative 16 is 24. So just subtract the real parts directly. Negative 10i minus 2i is minus 12i. Just subtract directly on the imaginary parts. Okay, now remember this. They want the imaginary part to only be the number, not the I. I don't know why this would be the way they would do it. I'm actually confused. The imaginary part clearly has to contain the I, otherwise it's not imaginary. But they only want the number. They do not want the I at the end. Again, I have no idea why. In my head, the I should be here because that's what's indicating that it's the imaginary part. So just be aware of that they don't want you to include the letter I. If I had put an I here, I would have gotten it wrong again. What type of number is 2i minus 7? This is only complex. It has an imaginary component, and it has a real component, but it's not real because it has an imaginary part. It's not imaginary because it has a real part. So this is just complex. Plus or minus the square root of negative 25. Well, the square root of 25... Oh, that is so bad. There's a reason I have this tablet. Okay. Okay, let's go green. Alright, so we have the square root of 25. That just equals 5. The square root of the negative 1 that we're pulling out as well, that's I. Okay, so we're going to end up with 5i. Next question. Negative 4 plus 2i. This is the real number line. We want negative 4 right here. This is the imaginary number line. We want positive 2i. Okay? So this is over at negative 4 plus 2i. This is my real component and my imaginary component. Don't do a bunch of points. Just do the point you need. Negative 4 plus 2i. We have to find the solutions to this quadratic equation. Right, so we have negative 5x squared plus x plus 2. Okay, this does not look like it's going to be a load of fun. The first thing we know, right, or let's write down what we can just look at and figure out. Right, remember x equals negative b plus or minus a square root of b squared minus 4ac all over 2a. Okay, and then we're just plugging these numbers in directly. Negative b, negative 1. Not negative, not negative, not negative. I already know which one's the correct answer. We're going to figure this whole thing out just to make sure we're right. Oh, no, I don't. I'm stupid, because we're going to have the negative on the bottom. So actually, this is the only one that's right. This one, or wrong. These ones might be right. And so I would do the whole problem. If I had just picked that, I would have gotten it wrong. Alright, so -1 over plus or minus the square root b squared. Right, so 1 squared, just 1, minus 4 times 2 times -5. 4 times 2 times -5, all over 2 times 5, which is 10. 2 times -5, which is -10. Right, so we're getting 1/10. So we know this one is wrong, right? We have to have 1/10 in the front. -4 times 2 is -8. -8 times -5 is 40. So we actually end up with 1 plus 40 on the inside, or the square root of 41. That's this one right here. That's this one right here. Now, you may have noticed that they flipped the plus or minus upside down. That's because it's over the -10, so the plus becomes a minus and the minus becomes a plus. We never write this minus plus, ever, in math. This is just a Khan Academy thing and some other places that like to do it in high school, maybe in some lower level college classes. Plus minus equals plus minus. The only reason you would do this to indicate it is to indicate that the sign switched somewhere during the problem. We don't care that the sign switched during the problem typically. But this one's interesting because we did not end up with an imaginary component. The answer is actually not complex. So don't just pick one that has an I in it. Which of the following is the equivalent of the complex number I to the 38? We already talked about this. Anything that you can write as I to the 4th times a number, right, is just going to equal 1. Well, that's to the 38th, right? So I to the 36th is equal to 1, right? Because this is I to the 4 times 9, right? And I to the 4th is always 1. And then 1 to the power of 9 is just going to be 1. So I to the 38th, we're multiplying it by 2 more i's, right? We're doing 1 times another I, right? That gets us up to 37, times another I, that gets us up to 38. Well, I times I is -1, 1 times -1 is -1. Oh, I only have one rectangle here. Okay. My recommendation on these, do some of the practice first. Feel comfortable. When you get down, if you want to start off with a unit test just to see where you're at, that's not a bad idea. And then anything you're getting wrong, come back to the practice problems. Read through the hints. Check out the videos. If you're getting stuck or you're having problems, something's not making sense, email me, let me know, and I'll see what I can do to help out. And I will talk to you guys later.